These are your 9-4B notes. We're going to solve quadratic equations by completing the square. We're going to build off of what we learned in the previous lesson as to if you have a perfect square of one side equal to a number, you can take the square root of both sides and solve that way. So the only difference today is that the trinomials on one side are not perfect. So you can't do this if they're not perfect unless you complete the square and make them perfect. So the process of completing the square makes any trinomial a perfect square trinomial. And I know you guys aren't really familiar with the language, but that means that it'll factor to some quantity squared. And so if we can get any trinomial to be that way, we can use the square root property every time. Some trinomials are easier to make perfect than others. We're limited. I just want to make a note that we're not going to be doing the really difficult ones today. So we save that for Algebra 2. But I'm going to just show you this technique of making nice trinomials into perfect square trinomials. We're going to move out the old c and add in new c. This is not a new technique. We did this when we put equations in vertex form. So when we had to complete the square in vertex form, if you remember, we used it to get this quantity squared. That's how we came up with that quantity squared. We are doing that same process. Okay, and so if you remember, back when we did that, the new c, the new perfect c, is half the b value squared. So like I said yesterday in class, we're kind of just taking two old concepts and combining them. Once you get it perfect squared, you're just going to use the square root property like we did before. Okay, so beyond that point, once we get the quantity squared, we're going to do what we did the day before. So we just have a couple extra steps in the beginning of our process. So we're going to jump right into trying these. So this is different than factoring, and it's different than graphing to solve. When we solved by graphing and factoring, we moved everything to the one side and got it equal to 0. This is the two strategies where we do not do that. Was yesterday when we took the square root of both sides, and then today. So we're going to leave that 12 on the right-hand side. And in addition to that 12, we're going to move out this ugly 5. So we're going to bring this minus 5 to both sides. We're going to bring it over with that 12. When I move out the old c, I'm left with x squared plus 6x. And I'm just going to leave a space for my new c. I'm going to plan ahead. I got to bring in somebody else to replace that 5. Is equal to 7 plus new c. Okay, I got 7 from 12 minus 5. So now I'm going to go off to the side here, up in the corner, and I'm going to take my b value, which is 6. I'm going to take half of it, and then I'm going to square it. And so that's 3 squared, which is 9. So the c value that makes this trinomial perfect is a positive 9. So I'm going to add 9 to both sides. By doing that, I created a perfect square trinomial here. And so it factors to something squared. What multiplies to give me 9 and adds to give me 6? X plus 3, or the quantity x plus 3 squared. On the right-hand side, 7 plus 9 is equivalent to 16. So now we're right where we were when we used the square root property. So for those of you that did not watch those notes, pay attention. You have something squared on one side. We're going to take the square root of it to undo the square. Whatever you do to one side, you have to be consistent and do it on the other side. So we took the square root of both sides. The square and the square root cancel each other out. They are inverses of each other. They undo each other. So we're left with just the quantity underneath, x plus 3, is equal to the square root of 16. And the square root of 16 has two solutions, positive and negative 4. So when I solve for x, I'm going to subtract 3 from both sides. But when I subtract 3, I have to subtract 3 from a positive 4. And I have to subtract 3 from a negative 4. So 4 becomes a positive 4 and a negative 4. The 3 stays negative 3 because that's what I did to both sides. So 4 minus 3 is 1. and negative 4 minus 3 is negative 7. So my solutions, I have two solutions, 1 and negative 7 there. Okay, let's just try it again. So a lot of repeat steps here. So for the second one here, it looks like another positive 5 that I'm going to move out. So I'm going to bring out old 5 by subtracting 5 from both sides. Okay, and then I'm going to leave room for my new c value, x squared minus 18x plus room for my new c value is equal to 6 plus my new c value. I go off to the side, and I'm using negative 18. I take half of it, which gives me negative 9, and I square it, and I end up with 81. So I'm going to add 81 to both sides. That is my new perfect c value. That makes this whole trinomial a perfect square trinomial. We ask ourselves, what multiplies to give me 81 and adds to give me negative 18? Negative 9 and negative 9. Or the quantity x minus 9 squared. That is equal to, this 6 plus 81 gives me 87. Well, 87 is not perfect, so we're going to get an ugly decimal. But I tell you what, I'm going to leave it as the square root of 87 until the very end. It's easier to write down. So now I'm ready to use the square root property. Take the square root of both sides. The square and the square root cancel. X minus 9 is equal to positive negative square root of 87. Just leave it in that little square root symbol until you're ready to do the calculations. So we're going to add 9 to both sides. And so here's what x is equal to. X is equal to two different values. It's equal to 9 plus the square root of 87. And x is also equal to 9 minus the square root of 87. Just want to point out, 9 is positive in both cases because we added 9 to both sides. The only thing that changes signs is the square root. So when I have 9 and I add it to the square root of 87, I'm getting 18.3-ish, about. And when I take 9 and I subtract the square root of 87, I end up with negative 0.3. And so my two solutions are ugly, but there's still two, 18.3 and negative 0.3. Okay, that just means that the parabola, we're still talking about a parabola, hitting the x-axis at two spots. They were pretty ugly spots. All right, a couple more. We need to complete the square here, okay? In these two instances, there is no c value. That's okay. And so when there is no c value, we just create a c value. And so x squared plus 4x plus room for my new c is equal to 6 plus my old c. Or I'm sorry, my new c. I'm going to go off to the side and use the 4, that's my b value. Take half of it, which is 2, and square that. And I'm going to add 4 to both sides. So when I add 4 to both sides, I end up getting a perfect square trinomial. What multiplies to give me 4 and adds to give me 4, x plus 2 squared is equal to 10. Take the square root of both sides. The square and the square root cancel. X plus 2 is equal to positive and negative 10, square root of 10. I'll leave it as a square root right now. I'm going to subtract 2 from both sides, and now I'm ready to write it down. So I have negative 2 plus the root of 10 and negative 2 minus root 10. And those are going to be approximate, decimal approximate. So I used that squiggly equal sign. Negative 2 plus the square root of 10 is 1.2-ish. And negative 2 minus the square root of 10 is negative 5.2. Okay, one last time, and then you guys can try it on your own. So for this one, we're going to bring in a new c value. I've got x squared minus 8x plus room for a c value is equal to negative 16 plus a new c value. I'm going to go up top and figure out what that perfect c value would be. I take my b value, negative 8, divide it by 2, gives me negative 4. I square it, and I end up with 16. I add 16 to both sides. This trinomial becomes perfect. That's the whole concept of completing the square. X minus 4 squared is equal to 0 this time. From yesterday, when you take the square root of 0, you're only going to get one solution. Okay, so the square and the square root cancel. X minus 4 is equal to plus or minus 0, but plus or minus 0 is just 0. So I'm going to add 4 to both sides, and I only get one solution, and my solution is 4. That is solving by completing the square. Before I give you your homework or your practice problem, I just want to point something out. I only showed you how to do this when my lead coefficient, my A value, was a positive 1. You can do it when A is negative. You can do it when A is a number other than 1. It's a little bit more complicated, and so I have not shown you that way. So if you have an A value that's not equal to 1, you do not know how to use completing the square. Okay, so I wanted to point that out, that you can do it when it's not 1, but it does change the process a little bit, and you're not ready for that. That's something we share with you in Algebra 2. All right, so what does completing the square do? Okay, that was kind of the whole focus. And then actually solve by completing the square. And good luck.